Are you a student struggling to keep up with your lessons? Or a parent searching for a reliable educational resource that truly cares? You've come to the right place. Welcome to FEUNIX Distinctions, your premier channel for educational content designed for every learner. We understand the silent struggles that often go unnoticed, the frustration of slow-paced learners, and the need for solid foundations for all students. At FEUNIX Distinctions, we don't just teach. We are dedicated to guiding you every step of the way. Our teaching style is unique, simple, and incredibly effective. We make complex concepts easy to grasp and ensure that every lesson is both suitable and enjoyable, no matter your learning pace. Whether you're a fast learner looking for a new challenge or an average learner aiming to excel, our comprehensive methodology is built to support you. Join a community where no one is left behind. Subscribe to FEUNIX Distinctions today and hit the notification bell so you never miss a lesson. Let's make learning an exciting journey together.
I welcome you students to today's class. This is SS2 Mathematics class lesson 6. Our topic is psychogeometry. In lesson 5, we started this topic, psychogeometry. And we're dealing with chords and arcs. So in lesson 5, we solved some questions. Some questions that have to do with Theorem 10. So we are not going to waste time. We'll move on to Theorem 11. We're going to see Theorem 11, then we'll solve some examples, and then I'll leave you with some work to do. Let's quote this Theorem 11. Theorem 11 states that the angle that an arc of a cycle subtends at the center is twice that which it subtends. At any point on the remaining part of the circumference. Remaining parts of the circumference. So in this Theorem 11, we are looking at angle at center. That is, I'm summarizing it. Angle at center is twice angle at the circumference. When you have angle at center, that angle is twice angle at the circumference. I'm going to use an example to explain this. Angle at center is twice angle at the circumference. Let's get a cycle in order to explain this. We have a cycle here. In order to explain, angle at center is twice angle at the circumference. This is the center of a cycle. We call it center O. If we make an angle here, let's say here is an angle. And then we make an angle also at the circumference. So let me call here A, B, C. Here is the relationship. What theorem 11 is saying. This is the angle at center. This is the angle at circumference. So, okay, let's get it clear. If this is angle at center. If this angle is, let's say 20, then this angle at circumference will be 10. Because the theorem said angle at center is twice angle at circumference. So you can see this 20 is twice this angle 10. Now there is something very important to note. You see that this angle and this angle, they are facing the same direction. They are facing down. They are facing down. The two angles are facing down. So that's one of the ways you can know this. The direction of the angle matters. And then the takeoff point and the landing point matters too. These are the 2 points to note. Now, like this very angle, this angle at center, that I call angle 20, it starts from this point A. This is the takeoff point. This is the takeoff point from to this place, and then this is the landing point, this point B. This is where it lands. So these are the legs here, this very one and this very one here. This is the takeoff point, this is the landing point that forms this angle. The same thing with this very angle at circumference. It has the same takeoff point. It starts from this angle A, this point A, and so this is the line. It touches the circumference and returns to this very point B. So the two angles have the same takeoff point and landing point, and they are facing the same direction. These are the two things to consider in order to avoid making mistakes. The angle at center and angle at circumference, they must have two properties. One, they must have the same takeoff point and landing point, and two, they must face the same direction before we consider them as angle at center and angle at circumference. Then angle at center is always twice angle at circumference. So if angle at circumference is the one that is being given to you, let's say for example, this angle is given as 5, then what will be the angle at the center? The angle at the center will be 10, because angle at center is twice. So if you are giving angle at center to find angle at circumference, you will divide by 2, because angle at center is twice that of circumference, you divide by 2. Or if you are giving angle at circumference to find angle at center, you will times it by 2. And that's the logic. So let's solve an example so that we can see it. Here's a question here. Find the lettered angle. Find the lettered angle. Let's find the lettered angle. So we have a cycle here, and then we have our straight lines. Here are our lines here. So let's say this is the center here. This is center O. Now here we have Q, and here we have 41. We have 41 here, we have Q here. So the lateral angle here is Q. To find this Q is very simple. Angle at center is twice angle at circumference. If angle at circumference is 41, the angle at the center will be times 2 of the angle at circumference. Now what makes us believe that this is angle at center and angle at circumference? Because they have both angle Q and angle 41, they have the same takeoff point. This one take off from here and it landed here. And then angle Q also take off from that same point and landed at the same point. And angle 41 is facing down and angle Q is facing down. So the direction matters. The takeoff point and the landing point is one of the things you must watch out for. And then the direction must be the same before we can use this theorem. So since angle at circumference is twice, so therefore angle Q will be 41 times 2. That is being twice. Angle Q will be 82 degrees. And that is our answer. Let's solve another example. Example 2. In the figure below, O is the center of cycle WXYZ. WXYZ. Full stop. If XWZ with the angle at W is equal to 35 degrees, find XOZ and XYZ. Let's get our cycle. Here is our cycle. And then we are going to draw our lines. So we have our center O. This is X, Y, Z. Let's have another line. This angle is angle 33. So now the question said we should find XOZ. XOZ. This is X. This is O, that is this middle, and this is Z. So they're asking us for this angle XOZ. If we are to get angle XOZ, that is this very angle that looks here like this, and this very angle here, this is XOZ. If we are to get this angle, we will apply this same theory. You will see that this very angle have the same takeoff points and landing points with this angle 33, and they are all facing the same direction. This angle 33 is facing down, and this very angle is also facing down. They have the same direction, they are facing down, and they have the same takeoff and landing points. So therefore we can use angle at center is twice angle at circumference. Angle 33 is angle at circumference. So this very angle XOZ, that is this angle, should be twice the angle 33. That is to say, angle XOZ will be equal to 33 times 2. That is equal to 66 degrees. It gives us 66 degrees. Remaining XYZ, angle XYZ. Angle XYZ, that is this very angle here. This is angle XYZ. If we are to use this same theorem, you see that this angle and this angle 33, they are not facing the same direction, so we can't make use of it. This one is facing up, this one is facing down, and we cannot use this angle and this very one, this one at the center here, because this angle is facing up, this one is facing down. We can't use it. The angle that we can use is this other angle here, the other side of it here, because this angle is facing up and this angle is facing up, and they have the same takeoff point and landing point. This angle took off from this X and landed at this Z. This is it. It moves this way and it landed here. And the same thing with this angle, it took off this from the same point, it goes this way, and it landed at this Z. So they have the same takeoff point and landing point. So we need to know this very angle here. We need to know this angle here. How can we know it? If this angle is 66, this very one that we found is 66, we can get this one using sum of angles meeting at a point for a complete cycle. A complete cycle is 360 degrees. So if this one gives us 66, the other way around will be 360 minus 66. It will be 360 minus 66. 360 minus 66. That will give us 294. 294 degrees. So this angle is 294 degrees. We can use it to get this angle that we're looking for now. So the angle at circumference will be half of the angle at the center. That is to say, angle XYZ will be 294 294 to be 294 divided by 2. We do this division, we are going to have 147 degrees. So I'm going to give you some work to do as assignments. I'm going to leave you with assignments. Find the lettered angle. One. Find the lettered angle. Here is 106 degrees. This is center O. And then this is angle X. Angle X. So you have to find this angle X. Let me leave you with another question. So here we have 126. This is center O. This is the center. And then this angle is angle Y. This is angle Y here. This very angle is angle Y. So I want you to solve these two questions. And then in the next lesson, that is lesson 7, I'm going to give you the correct answer. From there, you are going to know if your work is correct or not. So don't forget to follow us to the next lesson, that is lesson 7. So thank you very much. Always click the subscription button and then watch out for the next lesson. Thank you.